burn through this, not that exciting. I work at GoDaddy. More exciting than that, I'm part of the Ray Wendelich team. More exciting than that, I wrote a book on debugging. I will be using a lot of the LLDB scripts from this book. Because I'm totally not trying to like secretly sell you this book. But if you like what you see in this demo, you should consider checking it out. It's, I'm proud of it. And here are my happy repo scripts. You know, like I kind of just want you guys to chill and take it easy. You don't need to install it and do all this stuff now, so probably what's easier is to just Google this, LLDB Derek, should pop up. Okay, so all my scripts are in there. So, just to give you a heads up, I have a pretty tight schedule. There's a lot of stuff I wanted to have in here that I just didn't have time. Like I wanted to talk about XPC, I wanted to talk about the Mako file format. I don't have time. So I got one kind of theory thing where I'm going to showcase to you how I explore Objective-C blocks in memory using LLDB. And I think this is kind of insightful for some of you, either from a debugging standpoint or from a security standpoint, like how people can go about like exploring this stuff. We don't have the source code. Then after that, we're going to do a demo on SpringBoard. Specifically, what are we going to do? My first objective is I want to go after this carrier thing in the upper left corner. Okay, not only do I want to know what kind of UI view it is, I also want to know how and where it's created. So I want the stack trace for it. And I'll show you some creative ways of finding that out. Next example is I am a big fan of method swizzling. So we are going to go after the scroll view and do some crazy CG transform stuff just to show you what's possible. I feel kind of vexed. I've used this example in the past talk, but I really like showing it because it's like it's super clean and doesn't. It's a lot cleaner than other things I'll do for swizzling. And then finally, have any of you guys heard about this dude? Yeah, okay. So some of you might have heard about that HomePod, firmware stuff a couple weeks back, right? They, released a bunch of info, all that stuff. This guy, he when the iPhone betas came out, he had a couple nice tweets on how to enable drag and drop. So I'm going to try and figure out what he's saying here, debug it, and see if I can enable drag and drop on the iPhone, if I got time. Okay, so let's get into that theory, and then we're going to have fun with the demo. Often when I don't know where to start, I'll always search opensource.apple.com. That is a great place to find all your structs. It doesn't matter if you're working in Objective-C or Swift, everything boils down to a C struct. So, an Objective-C block, at the very start, offset 0 has that void isa. I'm sure some of you working with Objective-C know that this is how retain release cycle stuff, this is like NSObject 101. After that, we have something called flags. After that, we have an int for reserved. And this is kind of interesting. We have this invoke function pointer. So this is going to be the function pointer that's going to point to the actual code that's going to get executed in the block. This dude you can hear, ignore it for now. I'm going to swing back to it when I'm exploring it in memory. After that, the compiler will automatically import all the variables that you're referencing. So it's smart enough to say, hey, this variable outside the block scope is being referenced inside the block, therefore I'll import it and have it be part of this block layout. Okay, so I'm going to stick this in the, let me back up. Let me do a concrete example with actual code. 3 ints up top, ABC, a variable called long, variable called called D, which is a long. And then in a string, and all these are just being referenced in a block. Nothing crazy. Okay? So I'm going to put this in the upper right corner. I'm going to put that, that block layout in the upper left corner. Let's check this out in memory. I'm in LLDB right now, right here. For some of you who are familiar with the x86 64-bit architecture, this is the RDI register, which is going to be the first parameter. You guys don't need to know this. I just want you to know that this register RDI is referencing a valid instance of an Objective-C block. That's all you need to know.
Does LLDB have any shortcuts to those, to which register is which? Because I always have to look it up.
Register, oh, well,
like,
the register column can
dollar or something, like I just want dollar or one.
Oh yeah, you can do, that's exactly it. So RDI for the x86 is going to be R1.
Oh, it's what I just said.
Yep.
I could do, oh.
Yeah. Or if you just want to do register read, or more simple for my head is reread, RDX. You don't have to do that stupid dollar sign, and that also, more importantly, works in Swift. Okay, let's examine this memory. This is a popular GDB command that I ported to LLDB. What this does is it says, examine the RDI register, formatted in a giant word, which is 8 bytes, 64 bits, 8 bytes. Do this 8 times, formatted in text. So each one of these is going to be 8 bytes long. Okay, so we're going to take this, and now we can just like correlate the block layout to the memory that's being dumped out. So here we have that ISA. This is going to be that NSMalloc block class. This is kind of interesting. There's two amusing things here to note. So the int flags, an int in a 64-bit process is going to be 4 bytes. So that's going to be half the giant word of 8 bytes. Okay? The other part that might confuse or trick some people is that you might think it's right up there in that left-hand corner, but this is a little Indian architecture, so all this stuff is flipped. So you always need to be careful about the memory sizes you're parsing, or else you might screw it up because flipped around on you. So after that, we've got a reserved. After that, we have our invoke function pointer. Here's another custom command that I have in that repo called info. So what I'm doing here is get this address, figure out the info of it, and it'll tell me that this address is in the text segment, in the text section. By the way, all your code is going to be in this section right here. Doesn't matter for any module, it could be your own code, it could be UI kit or foundation. Will almost always be there unless you change it specifically. And I can see that it's in, this block is going to be in app delegate, application loader, foreground, block, and book. Okay? So that's the actual function pointer for the code. After that, we have that block descriptor that I said I was going to talk about. Still not yet. We're now going to the variables. Here we have that in a string called foo. After that, we have the D, which is a long, is going to be 8 bytes, so it takes up the full giant. Then we have our 3, our 2, then our 1. Okay? And let's talk about that block descriptor. Oh yeah, I forgot about this. So in the upper right, I changed around the code. This is another struct you can find at opensource.apple.com. I don't really care about much, but I do care about the second value, size. What's up? Oh, there we go. I'll just stick with my safe bar. No, that's good. I got my safe bar. So, okay, so here is the block descriptor in memory. I'm saying dereference this, and format it two giants, formatted in X, and we get 0 to X, receive. Each of these is 8 bytes long, so this will tell me the size of the block. So if I want to count, I'm going to count X. 8, 10, 18, 20, 28, 30, 38. We got that A, which is only 4 bytes. 39, 3A, 3B, 3C. So if I don't have my source code for something and I'm going after a block, that's how I'll go about doing it in memory. Okay? Now, let's have some fun. All right. All right, here's SpringBoard. I'm a big fan of just using LLDB in the console. Xcode seems to crash less when I don't have to rely on Xcode. So, I'm going to use LLDB. I'm going to say, hey, LLDB, attached to SpringBoard. And I'll say, okay, let me think about it. And then, okay, there we go. So, I have a lot of tweaks in my tilde/dot LLDB init. If you don't buy the book, you better go rewatch his talk on LLDB. Like whenever the videos come up, it's awesome. Okay, so when I started doing this stuff a couple of years back, we'd always do PO something, and this is what I did back in the day. So I did PO UI app, that's going to be the app delegate. From there, probably key window, root view controller, maybe I'll class dump it, child view controller is object in there flat, and go from there. But there's much more elegant ways of going after this thing. Okay, but before I do that, I'm going to start up really, really high and then hone in onto the LLDB module. So I said module. What is that? Let's list all the modules known to the SpringBoard process. 541, SpringBoard 0, dynamic link editor is number 1. Let's see. And so these are all could be the main executable. This could be NS bundles. This could be dynamic libraries. This could be frameworks. Just stuff that gets loaded into the process. But that stuff is something I can explore. So I have a custom command called lookup. And, let me go back up. Let's see, what do I want to explore? Let's go after weather. Okay? So I want to figure out what's in this module. So I can do lookup, custom command, anything, takes a regex, and I want to only look in the weather module. Now LLDB is going to take a second because it's thinking about, hey, where are all these modules, and I got to find all these symbols and stuff. So there we go. And scrolling all the way up, we can see that I was able to find 1,400 hits inside the weather module. Now this takes a regex, so I can get kind of smart with this stuff. So let's say I want to search for a space. This is just with the S meta character, that's going to resolve to a space in the regex. I'm going to say shared. And let's say I'm going to do the W meta character. That's going to be an alphanumeric, including underscore. 1 or more. Closing bracket. Nice, and no more. Because sometimes, I get these block invoke methods. I don't want that. I just want just a clear cut. Done, that's the end of the method. Look at a bunch of singletons I can put up. Okay, so I can, take this doohickey here, clear the screen, PO, okay, there's a singleton. I can also, since it's a valid instance now, I could run some other custom things I have for methods. It'll dump all the methods out. I could do IVARs, get all the IVARs from this thing. I could quickly figure out what this thing is, how it's being used, and all that fun stuff. Okay. So I like the lookup command. Well, let me show you one other cool thing. So I also have when I am clueless on where to search. All my commands have a lot of options. So I have this summary option. So let's say I want to do lookup, and I want to do a case-insensitive search for the word malloc. I don't know where I'm going, I don't know where it could be, so I'm just going to say, give me the summary of everything. And I can see that there's quite a lot of hits. This is probably what I want to go for. Okay, I'll explore that. Change this around to only search within the live system malloc. Okay, now I can find probably what I'm looking for on there. Okay. I talked about code, so let me talk about classes now. Objective-C classes. Swift data in here yet. Not in the SpringBoard yet anyways. We'll see something amusing soon about Swift, but for SpringBoard it's only Objective-C at the moment. Was it D class? This is a shorthand thing for dump class. So we'll dump all the classes known to the SpringBoard process that are Objective-C. It's a lot. I can filter by module. Okay. Still a lot. So these are only the classes implemented in the SpringBoard module. Some of you who do work with the Objective-C runtime, there's like that, what is it called? It's like Objective-C classes for image or something like that. I forget the exact name. But how does that API work? Okay, let's find out. Another command called section. This is a little misleading. These are actually called the page 0 text data link edit. They're actually segments. But I'm going to drill down into the data section, the data segment. But I wish I could talk about these. I could quite literally spend the whole day on these 4 segments. They are very cool, and if you know how they play with each other, you can do a lot of reversing fun stuff. But anyways, data. And by the way, this pertains to every module. So let me back up. If I want to go after UI kit, every module is going to have this. Okay, I wanted to go after the data segment in the SpringBoard executable because I was going to talk about classes. There's this nice little section, subcomponent. So data segment underscore Objective-C underscore classes is the section. Here's going to be the size of this thing. Here's going to be the start address. Here's going to be the end address. So if I were to just dump this thing at the start address, let's just do 40 or something. These are all going to be classes. Doesn't matter which one I pick. These are all going to be classes. Okay? So, how can I quickly find out how many classes there are in the SpringBoard module? Oops. Get the size of it. Print in decimal format the size of this section divided by the size of a pointer to a class. In a 64-bit process, all pointers are going to be 8 bytes in size, but here's a nice quick way to see, okay, 1,300 classes in SpringBoard. All right, let's see what else we have. I'm going to go back and explore more sections in the data segment. There's so many fun things that you could do in here. It's like, especially in the text segment as well. The text segment, like I said, is going to store your code. It's going to, that segment is going to be writable and executable. Unlike the data segment, where it's going to be readable and writable, but not executable. Okay, let's go to that BSS section. This is the place where all your static variables are going to be declared. So if you have your dispatch once and all that stuff, like the dispatch once token, it's going in there. So let's look at the start address. I like that ring. That's cool. Let's start Let's dump 40 of these in giant word in hex at the start address. Okay. This may not look like much, but I can already tell, if I can find my mouse, this is going to be an Objective-C class. And this was made in a dispatch once. This reeks of kind of a dispatch once signature, where it gets set to -1 after the dispatch once has been called. Okay, do you believe me? Probably not. Let's look at it. Okay, SB Reachability Manager. Well, how can I find out if there's any methods I could inspect? Well, let's take this. Let's clear the screen. I'm going to look up SB Reachability Manager inside the SpringBoard module. Cool. I get it. Why is that? In the main executable, the symbol information is stripped out, unlike in a dynamic framework. Okay, so I can still reference all this stuff in a DLib, but I can't get this Objective-C info out of the main executable. Fortunately, I can use Objective-C against itself and dump everything out. Okay, let's get a little fancy. Let's search for. I want the load address. Okay, cool. And I want only class methods for this doohickey. Or no, wrong way there. Hey. I wonder where that got instantiated, that static variable. This is the load address of SB Reachability Manager shared instance in memory. Let's dump this in disassembly. All right. All right, what do we got here? The green on the right, kind of gives you a hint. Okay, so this memory thing is in the data ESS section. Notice how the first two, there's only an 8-byte difference. Okay. All right. So we can take this thing. I'll just dereference it again. X2, GX, and we're back to square one with our lovely little instance. Okay. So again, I got it from here. Dereference it, print it out. By the way, for those of you who are curious how I do this, this registers the instruction pointer. So it's basically just a pointer to each line's code or assembly and executing it, right? However, some of you might think that this plus this will give me this, and that's not the case, because how your CPU works is it'll increment to the next instruction and then execute it. So I'm not going to grab this one up here. I'm going to grab this one right here. Oops, px u plus u. Okay, now it'll give me the what was it, 99D8 is right here. Okay. Let's see, what else can I do? Let's see. How are we doing on time, by the way? Good? Okay, sweet. All right, so let's try another way of referencing this. I'm going to do that DD command again. Another way to accomplish the same goal is you can reference, you could search the binary, x-reference it for this particular value, wherever it is, right there. Right? So I can do xref, try and figure out where this pointer to the SB Reachability Manager resides. Okay, so I get these strip functions. 420, 421, 421, duplicate, whatever. 420. Guess we are in Colorado. All right, so this is going to be the location of where this value is being referenced at. Okay. Oops. So it's going to be at LLDB unnamed symbol 420 plus offset 10. So what we can do is, again, this is actually a command I have you build out in the book, is how to use the Objective-C runtime to kind of re-symbolicate itself. So SBT A, get this address. Okay, so that's another way of re-accomplishing the same objective. Okay, I got distracted, so let's talk about, let's go after that doohickey, that carrier thing in the upper left corner. To do that, I'm actually going to do something kind of sneaky on you guys. LLDB simulator. I'm attaching the sim now, not SpringBoard. Or both the simulator and the SpringBoard are now frozen, sig stopped. Okay? I'm going to use one of my favorite commands, search for an NS window. Okay. This command will enumerate the heap, and it'll try and find certain objects that fit into a certain type of class. This is not the only trick it can do. I'm going to say perform for all instances the following. I reference each instance through obj, set level 8. So here's what I did. I want the simulator to be in front of my turn window, even though the turn window is first responder. So that way I can toggle views and do all this stupid crap, and I don't have to switch back and forth to show you what I'm doing. By the way, what's interesting about those classes? Come on, all you sort of developers out there. What?
They're like part of the simulator module, right? So they have the DOM.
They're written in Swift. The dot, the module, the simulator module, and then the dot is the dead giveaway that this is Swift. All right, let's continue. I'm going to bring this down here. Pause the process. I have weird shortcuts for stuff, so GG is good game in my head, which translates to sig stop, so whatever, Derek. Okay. D class. Search for all classes with the following regex. It's resolved to, I'm searching for all classes that have a period in them. Cool. They are actively working finally in Swift in the simulator. Okay? And if you don't believe me, we could always do, we do section. We could do in the, sorry, segment there. And we can see that there are some Swift 3 sections inside the text segment. Okay, back to that carrier thing. So that was fun while it lasted. Okay, we're now in the SpringBoard LLDB session. Okay, so I'm going to use that search command again, and instead of NS window, I'm going to go after UI window because SpringBoard has a lot of windows, and I would like to know the starting point of where I want to drill down into. So let's search for all UI windows. Okay, found all the windows. By default, I dump out the object's description. Sometimes I don't like reading all that crap. It's too much for me. So I'm going to get the base name. It's much easier on my eyes when I don't have to go through all this stuff. I'm kind of looking for like a particular class that I want to go after. So let's see, root, notification, status bar. Oh, all right. It's a window. That means it's a UI view. That means I can toggle it on and off. Okay.
No, you can't do that.
Oh, it gets worse. Trust me. Okay, I found my starting point. I'm actually going to use a command that I like from Chisel. If you guys don't know about it, I strongly, strongly suggest that you go check it out. It's write down like Facebook, Chisel, GitHub, or something like that, and you're golden. But those guys know their stuff. I'll occasionally use some of their commands here and there. So PViews, one of them. I'm printing the view for that window that I just toggled on and off. Oh, okay. All right, there. All right, that's a lot of stuff. Fortunately, I've already done this, so I already know the exact one I want to go after. Make sure. Okay. Okay. What does this doohickey? Super class. Image. Oh, man. So, my objective is I need to go and figure out when this image got set, which kind of sucks because I could set a breakpoint on set image, right? The setter property for image, but you know, like we already know, without even looking, there's going to be a lot of images. So there is a more elegant way of doing this. Check this out. I'm going to open a new screen. I'm going to say LLDB attached to SpringBoard. But wait for a new process to start up called SpringBoard. On the top screen, I'm going to kill it. Proc kill. It's going to die. I'm going to get rid of the top screen. And the bottom one cut it. Cool. All right, I'm going to put a breakpoint on getM. It says no, nothing there, but I am so early in the process being executed that it wasn't even saying that. I've continued the process. Now I'm at a breakpoint, getM. So now I can do something sneaky. Let me just do all this and then I'll explain what I did in a second. Oops. Delete, continue. Who knows about malloc stack logging? Good. It's an environment variable. When set on your process, it's going to record all the stack traces when there's a malloc or free, depending on what settings you guys set on it. So what I did, what you don't know is that this can be toggled on at will using private APIs. I can do it whenever I want. So what I did was I caught the process nice and early. I know the dynamic link editor is going to call getM a whole bunch because that's where it figures out, hey, malloc stack logging is there. Just before SpringBoard has even loaded, and I'm going to enable logging. Okay. Clear the screen. I got a shortcut so you don't have to watch me fumble through all my stuff again. Search status bar. Oops, GG. Okay. That's another nice thing about that search command is I have a condition on it. So that's my condition to quickly hunt down this thing. It's going to be this one. Good. Okay. Now, PO, image, found our image. Now, this is another command I have you make in the book. Boop. So as we can see, lots of UI kit stuff. We have some SpringBoard stuff that I can't. It's not symbolicated. And I actually have you do this part too. Is I want you to re-symbolicate it. So I can figure it out. This has already happened in the process. We just have a record of it, and then we're referencing these addresses. Okay. So this looks like the app delegate. Objective 1 completed. All right. I'm going to go after number 2. That's some lovely swizzling. I'm going to kill the process because my stack logging stuff actually doesn't play nice with my search command at times, so I'm going to proc attach name SpringBoard again. Oops. All right, we're golden. Search command again. Let's search for all UI scroll views. Okay. Always forget to do the base name. Still too many for me to read. I'm going to search only inside the SpringBoard module. Okay, that's much better. I can. Looks like I do that one. Of course, I do my toggle view again. Okay. I found my SB icon scroll view. Okay, cool. So I want to swizzle this class somehow. Before I get into exploring that, let me show you another cool script I have. It's called S class or Swizzle class. Let's do a quick. Let's go after NSURL. So what this does is it'll look for every category or every method that's implemented directly in the scroll view. It'll make a NSObject category. And these are all methods that it generates, and I just turn it on or off or whatever. And down here are all the Swizzle methods that can be executed once I enable it. So if I, something cooler, if I did NSURL and I want to do a case-insensitive search to only Swizzle methods with the init with, okay, all these lovely doohickeys. So I have my instance for the UI scroll view. What was it again? I already forgot what it was. I'll just SpringBoard. There we go. It's you. So I want to go after probably the scroll view did scroll delegate. Okay. Let's see what we got here. Might have it, might not. Who knows? Let's see. Delegate. Okay. We could print the methods for this lovely thing. Methods. This is going to be the actual method in memory of where this starts. Let me show you a much more elegant way of doing this. Remember that lookup command? Lookup X, case-insensitive search. Scroll view did scroll. Okay, so far so good. Get the load addresses. Okay. One more. Create a breakpoint on all these addresses in memory. All right. Continue. About to drag in 3, 2, 1. Whoop. Okay, I have this thing called LLDB unnamed symbol. Since we're all pros at our x86 64-bit assembly, we know that PO, R1, but I like to do RDI. We could do XS for RSI, that's going to be the selector in Objective-C message send. And we could do RDX as the parameter, that's that scroll view that I just toggled on and off. Still though, there's a lot of methods in here. I don't want to do that, oh well. So which one is this exactly? Well, I have the instruction pointer. I could just compare that to the start of the method, right? PX, RIP. All right, C82A, C82A. It looks like you are the one. Okay, so I'm going after you then. S class. Only go after this method. Enable by default. Copy the compile instructions in the file. This is that C command, that's what it did, so let's see what I do in a sec with this. All right, I have the default stub. I actually have a snippet that I'm just going to do just so I don't waste your time. All right, you can probably kind of tell what I'm about to do. I'm going after UI scroll view, so I need to probably import UIKit. Compile this. Build this category. Compile it into a framework. Right out to here. I have another command. This is a shorthand command for DLOpen. For those of you who know that one, if you don't, just write this down if you don't know this DLOpen. Just write down DLOpen, DLSym. There's some cool stuff you can do with that. Imload temp.a.d lib. Success. If I gave it some bogus crap, not going to work. And delete all my breakpoints. Let's try. Whee! All right. Objective 2 is done. How much time have I got so I know how much to burn through this one?
About 6 minutes.
6 minutes. Okay. I'm going to run over about 3 minutes, okay? And we're all going to shoot upstairs for the final thing. All right. Look at this stuff again. What does this guy say? All right. Down here. Drag and drop on iPhone is gated by 3 things. Apple internal folder, drag-enabled phone, drag-enabled rules. That's not the case now in this current beta. UIKit press. Okay? We'll get to this one in a second. Actually, let me back up. I'm going to jump back to that to objective 2. Let me show you a cool little DTrace script. Sorry. This is the. I have you make this in the book. This is the final chapter in the book. Snoopy. This is going to be a DTrace script that will, for probably the 3 people that have done DTracing here, this will go after Objective-C code that's even stripped, only inside in the main executable. Okay. So if I were to, there's a lot of stuff that comes out of here. So if I were to just grep, let's do a case insensitive scroll, view, did scroll again, and continue. All right. Let's see this. All right, so my swizzle method and the actual method being called. Right? So this is a very nice, I'm grepping a lot. There's a lot more stuff that's being executed behind the scenes. There's just so much stuff that you're not going to see what I want you to show you. But I love using DTrace for exploring stuff. When I go after private frameworks, I'll start sometimes on Mac first, figure out how they do it, and just drill in from there. A lot of times with DTrace because it's a great tool to get information when you have no clue where to start. Okay. Kill that. Let's see. I'm gonna do another DTrace thingy here. Let's go after you. Let's try figuring out the scroll view, or sorry, the drag and drop stuff. So by default, I can't do any of that stuff. So I'm going to attach LLDB to what was it, mobile slideshow? Mobile slide. Come on here. Here's another DTrace script. I'm going to say pmodule, and only go after UIKit methods. Search for case insensitive, search for drag. Okay, continue. Good. Let's see if we get anything here. Nope. There we go. Welcome back to. Okay, so I just dumped, I'm searching for everything that has the word drag in it. That looks interesting to me. To explore it. Okay, I don't need you anymore. Kill. I don't need the DTrace script anymore. What was that, drag enabled? And use that lookup command. Lookup, give me the load address. Period's any character. Oops. Try that again. Okay, ooh, 2 interesting things. Is enabled by default. I'm not going to waste your time. I've already gone through this. Is enabled will call is enabled by default on particular cases. So I don't want to explore is enabled, but let's go after this thing. Stump the assembly. Put this down here. A tail call optimization. Okay, this will jump. Takes the instruction pointer, jumps right to here. Let's go after this. Don't be scared. I'm going to walk you through it. Okay. Keep an eye on the green content because that's. This is my script helping me out, so this is my stuff trying to figure out, okay, this is the section, this is probably what you figure out. GUI device, current device, user interface data. Okay? call, that's going to be the actual code that gets executed. Return address is going to be stuck into RAX. This is the return register for x86-64. It's compared to 1. Okay. User interface medium is basically a CDM. So -1 is unknown, 0 is phone, 1 is iPad. Is this device an iPad? Okay. Where will I compare? If yes, jump to 86 right down here. And, but I'm assuming I'm not an iPad, so I can't rely on that. By the way, where's 86? 86 call jumps to there. Oh yeah, here we go. So this is basically going to return early. Okay, well, I'm not an iPad, but we have some interesting stuff down here. We have a call, a direct call, not Objective-C message send, to something called UIKit user defaults. Interesting. Object for key, interesting. Drag-enabled phone, interesting. Bool value, another hint, interesting. Okay? So, let's, all right, let me get that value again. UIKit user defaults, print it out, and see what this is. Okay, in its user defaults, that means we can do all the usual methods on this dictionary representation. Okay, get all that stuff good. Let's see here. So I'm going to do the following. Set value, or set bool, there we go. Bool. Yes for key. Is a dragging enabled phone. Okay, and then of course, this is the data source when you synchronize it. Synchronize. Okay. Let's try killing this. So pkill, mobile slideshow. I know I'm over the limit. I'm going to try and finish this up in about 3 minutes. So I just killed it. I'm going to bring it back up. Okay, we got dragging enabled on the phone. Now, I'm not letting go. Press Command-Shift-H. Okay, that's the inner processing he's talking about, right? So let me quickly go back here. I don't have time to show my other cool thing about how I found it, but cancel on deactivation phone. Set bool. Oops, what did I do there? Okay, cancel. I'm going to do it again. Cancel on deactivation phone. No. Okay, and then synchronize again. Good. One more thing. You talked about the Apple internal folder. I wish I could show you this, but I don't have time. I need to cd into sim root, and then I need to maker Apple internal. Okay, and I'm going to kill this doohickey. Restart it. And make sure I got the right hardware device. What? All right, one last time. Hopefully this works, and I'll let you guys go. All right. Command-Shift-H. Ooh. 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 That's it. Thanks a lot. Like, very grateful.